Bonsuelo, everybody. More exciting examples of elimination and substitution. Most of these I'm going to do by elimination. Matter of fact, I probably do all of them by elimination if I have a choice. And I'll kind of explain why I choose that more often. But let's take a look at these things. Okay, so we have 4 problems. And just solve it. Again, what are we trying to do? We're trying to find all values that make both statements true. Okay, first of all, why am I going to solve at least number 1 by elimination? Is it possible to get a variable alone here in either equation and not have a fraction? No, you have to have a fraction. Now, let me just say this. If it says solve by substitution, you've got to do it by substitution, even though you're going to end up with fractions, as your work. But I left it kind of open to you here. So I don't like, you should know this by now about me, I don't like fractions if I've got an equation, okay? So what I'm going to do, first of all, is write these things in standard form. And again, the key here, I think, is to be neat. So we've got the first equation becomes 3x minus 4y equals negative 5. And the second equation just stays 4x plus 5y equals 1. Okay, now I have to choose whether to get rid of the x or the y. I don't think it really makes much difference here. I guess usually if one of them's positive and one of them's negative, I usually go for those because then I don't have to multiply by a negative and it's probably less chance of me making a mistake. So I'm going to get rid of the y's, but getting rid of the x's is fine here. It really makes no difference whatsoever. So I'm going to multiply the top one by 5. Because I can get them both to be 20. One of them negative 20 and the other one 20. I'm going to multiply the top one by 5 and the bottom one by 4. Okay. So if I multiply the top equation by 5, I get 15x minus 20y equals negative 25. And if I multiply the bottom equation by 4, I get 16x plus 20y. Now, here's where, I don't know why this is, but this is where people make mistakes. If there was some number here other than a 1, no one, you probably would never make a mistake. But as soon as that number becomes a 1, I don't know why, but people forget to multiply it also. So remember, you're multiplying everything by 4. So the 4x, the 5y, and the 1. So that becomes a 4. Okay, now, we're going to add those equations together. So we get 31x equals negative 21. Therefore, x equals negative 21 31st. Now, may I take that and substitute it back into one of the original equations, the x value for one of the original equations? Yes. And if it was a simple number, I would. But it's a nasty-looking fraction, so I don't want to do that. Okay? So what I'm going to do is I'm going to do addition again. And I'm going to start from here, the point at which I got, the general, each of them with x and y on the same side. So I got rid of y before. Now I'm going to choose to get rid of x. So I'm going to multiply the top one by, I think, negative 4. So that's negative 12x plus 16y equals 20. So I multiplied everything by 4. Again, starting at this step right here. Okay, everything by negative 4. And on the bottom, I'm going to multiply everything by 3. So that's going to be 12x plus 15y. And again, once I have that 1 over there, it's really easy to forget. I don't know why it is, but I can just say a lot of people do forget. And then I'll add them together. And we'll get 31y equals 23. So y equals 23 31st. So what's the answer to this? Negative 21 31st, comma 23 31st. That point, the x value and the y value, if I substitute it into the original equations, will make both statements true. Okay? All right, let's take a look at the second one. Again, what don't I like about this second one? I hope it's obvious to you. I don't like fractions. Okay, so I'm going to multiply. You know what? I just realized that I wrote this one incorrectly, so I'm just going to change it. That there should not be a y there. It should just be x plus 3 equals negative 3/4 y. Okay? So I'm going to multiply the top one by, I'm just going to get rid of fractions, then I'll worry about it. So I'm going to multiply the top one by 15. So that'll give me 5x plus 6y equals negative 60. So I multiplied everything by 15. Now, I'm going to multiply everything by, and you could bring the y over to the, eventually we're going to do this, bring the y over to the left and the 3 over to the right, but I'm going to do it in 2 steps. If you do it in 1, that's fine. I'm going to multiply everything by 4, so we have 4x plus 12 equals negative 3y. And then I always keep them together, so 5x plus 6y equals negative 60. And now I'm going to bring the 3y over to the left and the 12 over to the right. So that's 4x plus 3y equals negative 12. Okay, what can I get to be opposites here? Probably the easiest thing is y, because I can just multiply the second equation by negative 2. So I'm going to leave the first equation alone. And the second one I'm going to multiply by negative 2. So we have negative 8x minus 6y equals 24. Okay, so that's going to give me negative, when I add them together, negative 3x equals negative 36, and x equals 12. Now, at this point, I'm not going to go back and do addition again. It's fine if you do, by the way. Okay, but 12 is a fairly easy number to plug in. I don't, and technically we should plug it into one of the original 2 equations, but I don't mind if you plug it into this one of these 2 right here. That's fine. Actually, I guess it'd be more like one of these 2 right here. Once we simplified it. So again, technically we should do it one of the originals, but if you use one of those, that's fine. So I think I'll use the 4x plus 3y equals 12. Tell you what, you go ahead and use any one you want. I'll go back and I'll do it the way I should do it. I'll plug it into the first into one of the 2 original equations. So you could plug it into the first one or the second one. I don't think it's that big of a deal here. Second one probably looks a little easier, so I'll go for that one. So we'll have 12. So this is the second original equation. 12 plus 3 equals negative 3/4 y. And then we'll have 15 equals negative 3/4 y. Let's multiply by 4, so that's 60 to get rid of fractions, equals negative 3y, and then divide by negative 3, which would be negative 20. So then what's the answer going to be? 12, comma, negative 20. And again, what is that? That's everything that will make both original statements true. Okay? It's a pretty simple idea. All right. Let's go ahead and take a look at the next one then. Okay, let's put the x and the y's on the same side. So this equation becomes 2x plus 5y equals 7. And I'm going to move the 10 over, so we have 4x plus 10y equals 3. Now, doesn't matter which one you wanted. The x or the y is about equal here. But you know what? I'm going to show you something. Most people are going to multiply the top. Let's say we get rid of the x's. Most people are going to multiply the top one by negative 2. How about this? If we keep the numbers smaller, we can multiply the bottom one, or we can divide the bottom one by negative 2. So the first equation, but it doesn't really matter which way you do it. I just want to point out you could do it either way. So I'm going to leave the first one alone. And then I'm going to divide both sides by negative 2. So we get negative 2x minus 5y equals, oh, you know what? Yeah, I probably don't want to divide by negative 2. And the reason is because we have that 3 and 7 there. So forget that. I should have looked over at the 3 and the 7 because they don't divide evenly by 2. So, okay. So I'll just multiply the top one by negative 2. So it's negative 4x minus 10y equals negative 14. And then the bottom one I'm going to leave alone. And when we add them, we get 0 equals negative 11. Now, what does this mean? Remember I said you got to know what you're doing. Okay, you're trying to make both statements true, and all the variables drop out here. So, like, what does 0 equals negative 11 mean? Well, we've seen something like this before. Okay, that is a false statement. It's always false. There's nothing you can do to make it true. So what's the solution to this? There is no solution. There's nothing you can substitute for x and y that will make that statement true. If I was to go back and look at the graphs, if I was to graph these things, which you don't have to do, but those two lines would be parallel. They wouldn't cross at any point. Okay? All right, let's take a look at the last one then. So let's take x plus y equals 4. What happened there? 4y plus 8. And x minus y equals 2y plus 8. Let's get the x and the y on the same side. So we get x minus 3y equals 8. And on the bottom, we get x minus 3y equals 8. Now, at this point, I'm just going to go through. It probably doesn't seem like it's too necessary, but I'm just going to follow the same method. I'm going to get rid of the x. I'm going to multiply the bottom by x, by negative 1. And what do you get? You get 0 equals 0. What do we know about this statement? It's true. It's always true, kind of. Now, before we would have said all real numbers, but that's not the answer here. So the idea that all real numbers make it true, nada, not true. Do not write that, okay? What's this? We basically have the same line. So I'm going to scribble some stuff, and you don't really need to draw it, but just listen. Okay, we have the same line. All right, they overlap. Now, every point that makes one line true makes the other line true. But does that mean every point in the world makes both of those true? No, because this point out here, it doesn't make either line true. This point here, it doesn't make either line true. This point here, it doesn't make either line true. This point here, 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 here. All of these points don't make either one true, so they can't be part of the answer. Well, there are an infinite number of points that do make it true, but not all points make it true. Now, that may seem weird, but how many points are on a line? An infinite number. Does that mean every point in the world is on that line? No. So how do you write the answer? It's kind of weird, but what you do is you write, and I went through this on the last video at the end, but I didn't show an example. You write all xy points such that, and then you write the equation of the line. So what's the equation of this line? X minus 3y equals 8, okay? Does it have to be in a particular form? No. Like if you want to put it in slope-intercept form, that's fine. It doesn't matter. Like on the previous file, I showed it in slope-intercept form. That's fine. In other words, let me just get rid of this because you don't need to see this there. Okay. Let's say you decide to write this. I don't know why you would, but what would this be in slope-intercept form? This would be negative 3y equals negative x plus 8. And then if you divide by negative 3, we'd get 1/3 x minus 8/3. So could I write the answer? All xy points such that, sorry, that should be a y there. Y equals 1/3 x minus 8/3. Sure, that's fine. Doesn't have to be a specific form. I just don't know why you would. Might as well just leave it in the standard form if that's the form it's already in. But so what makes both of these statements true in number 4? Not everything. Not everything makes them true. There are an infinite number of things that make it true, but those points have to be on the line. So what you're saying by writing this, either this statement or this statement, is any point that makes that line true will make both of the original statements true. Okay. Now, at this point you're saying to yourself, this is all well and good, but this is cake. So when are we actually going to do something that's going to allow us to think a little bit? Oh, that magic word, think. So what's next around the corner? You guessed it, word problems. Things of beauty. See you then, Ponsuelo.